Have you ever really thought about how that thing you just ordered online gets to you? You click a button, and a few days later, a box just appears. Well, it's not magic. It's this hidden science called industrial engineering. It is the invisible engine that powers our entire modern world, and we're about to pop the hood and see exactly how it works.
I mean, just look at this. You've got robots, you've got assembly lines, you've got people making sure it all runs smoothly. It's a symphony of controlled chaos. And believe it or not, every single product you own has gone through a system just like this one, a system that's been meticulously designed to be efficient, predictable, and of course, profitable.
So that's the billion-dollar question, right? How do companies juggle millions of parts, thousands of employees, and the whims of unpredictable customers to deliver exactly what we want right when we want it? Well, that is precisely the puzzle we are going to solve today.
So here's our roadmap. We're going to start by trying to predict the future, figuring out what customers want. Then, we'll see if making it is even a good idea financially. After that, we dive into the master plan for production, get a handle on the art of managing supplies, and zoom out to optimize the entire system. And finally, we'll wrap it all up.
Okay, so every single business journey starts right here. Before a single screw is turned or a line of code is written, you have to answer this one simple question. And you better get it right, because if you make too many, you're stuck with stuff you can't sell. Make too few, and you've left money on the table.
Now, this process of making an educated guess has a formal name. It's called forecasting. And you have to understand, this isn't just a minor detail. It is the absolute bedrock of all business planning. Everything, from how much raw material you buy to how many people you hire, depends on this number. But how do you actually do it?
Well, it really comes in two main flavors. On one hand, you've got qualitative forecasting. This is what you use when you have no past data, like for a brand new product. You get a bunch of smart, experienced people in a room and use their collective brain power to come up with an estimate. On the other hand, if your product has been around for a while, you can use quantitative forecasting. This is all about the data, looking at past sales numbers and using mathematical models to project them into the future.
Okay, so let's say your forecast is in. You think you can sell 10,000 of your new widgets. Fantastic. But that leads to the next, slightly terrifying question. Will we actually make any money doing this? To figure that out, you need to find something called the break-even point.
It really boils down to a few basic ideas. First, you have fixed costs, things like the rent on your factory. You pay this whether you make one widget or a million. Then you have variable costs. This is the cost of the raw materials for each individual widget. Add those two together and you get your total cost. The whole game is to make sure your total revenue, the money you get from sales, is bigger than that total cost. And this math leads us to what is truly a magic moment in the life of any product. It's that specific point where the money you're bringing in finally covers all the money you've spent to get there. That, my friends, is the break-even point. When you plot this on a chart, it becomes crystal clear. That rising line at the bottom, that's your total cost. It starts with your fixed costs and goes up with every unit you make. The other line, the one starting at 0 and climbing, that's your revenue. And the exact spot where they cross, that's your break-even point. Before you hit that number, you're in the red. But every single unit you sell after that point is pure, beautiful profit. It's the minimum you have to sell just to keep the lights on.
All right, so we've predicted how many we can sell, and we've confirmed it's actually profitable. Now comes the really hard part. How in the world do we actually make the thing? This is where we leave the spreadsheets behind and head down to the factory floor.
The brain of this whole operation is a system called Production Planning and Control, or PPC for short. You can think of it like air traffic control for a factory. It's the nerve center that's tracking every single job, making sure all the pieces move together in perfect harmony. And PPC really breaks down into three main jobs. First up is routing. This is about defining the exact journey, the literal path that a piece of raw material will take through all the machines and stations in the factory. Next is scheduling, which is putting it all in a calendar, setting a specific start and end time for every single one of those steps. And finally, you have dispatching. That's the green light, the final command that says, okay, go. So the factory is humming along. But to keep those machines running, you need a constant stream of materials and parts. And that brings us to the very delicate balancing act known as inventory management.
And here's the fundamental problem. If you order way too much stuff, your cash is literally just sitting on a shelf. You're paying for warehouse space, for insurance, and you're running the risk that those parts become obsolete. We call those holding costs. But
If you order too little, you get hit with ordering costs from placing a ton of small orders. And even worse, you risk a shortage that could shut down the whole factory. So how do you find the perfect balance? With math, of course. There's a brilliant little model called the economic order quantity, or EOQ. It crunches the numbers and finds the absolute perfect order size, that magical sweet spot where the cost of holding inventory and the cost of ordering it are at their lowest possible point. It's the Goldilocks number. Not too big, not too small, but just right. But here's a pro tip. You don't actually need to manage every last nut and bolt with that same level of crazy intensity. The real secret is something called selective control. You focus your energy where it's going to have the biggest impact.
And the way we do that is with something called ABC analysis. It's basically the 80-20 rule applied to your warehouse. Your A items are the vital few, maybe just 10% of your total parts, but they make up a whopping 75% of the total value. You watch these like a hawk. And at the other end, you have your C items. These are the trivial many, tons of cheap little parts. You still manage them, but with much simpler, looser controls.
Okay, now it's time to zoom out, because a modern business is so much more than just a single factory, right? It's this massive, sprawling network of suppliers, manufacturing plants, warehouses, and shipping lanes. And yes, industrial engineering has tools to optimize this whole thing, too. One of the classic examples is called the transportation problem. Imagine it's a giant logic puzzle. You have 3 factories and 5 different warehouses you need to supply. This model uses some clever math to figure out the absolute cheapest, most efficient way to ship all your goods to meet demand everywhere.
And another incredibly powerful tool is the critical path method, or CPM. Think about any big project, like building a skyscraper. CPM lets you map out every single task and identifies the one single chain of tasks that determines the project's total length. That's your critical path. Any delay to any task on that path, even by 1 day, delays the entire project. It tells you exactly where you cannot afford to slip up.
So there you have it. We have gone on a journey from a simple guess about the future all the way to a finished product rolling out the door, ready to be shipped. And every single step was guided by the quiet logic of industrial engineering. But here is the most important thing to remember. This is not just about factories. It is a way of thinking. It's about looking at any complex system, whether it's running a hospital ER, managing a software launch, or even just planning a big family dinner, and asking, how can we do this better? How can we eliminate waste and make this whole thing run like clockwork?
And that really leaves us with one final thought. From the way you organize your morning routine to how you tackle big projects at work, where's the hidden chaos in your own life that's just waiting to be turned into perfect, predictable, beautiful clockwork?